up being special cases, so that maybe makes it a little bit trickier. So, looking at this problem, I'm hoping in number 3, you realize we should probably it's nice and lined up, so I would probably again use elimination for this. I typically won't use graphing unless I have graph paper sitting there and someone makes me. Graphing would not probably be my first choice most times. So for elimination, thoughts on what we could multiply by, because nothing will cancel the way it is.
2.
By 2 to which one? The bottom. And this was kind of like a question on our scrimmage, was where would you multiply and what would you multiply by? So the top equation is not going to change. The bottom equation, though, I'm going to multiply everything by 2. Because now I get a negative 16x, which is kind of what I was hoping for. I get a negative 12y, and then I get 12. So this is going to cancel. I get a negative 22y equals 22. So in order to solve this, we're going to divide by a negative 22. And we find out y is what? What's that?
1.
Negative 1. Once I know what y is, then I'm going to substitute that back in to find my x. Now, I typically like putting into the one with smaller numbers. I'm going to put it back into this, well, it doesn't really matter, but so I'm going to do negative 8x minus 6 times a negative 1 equals 6. And so this is where this one gets a little bit strange. And I just want to make sure, this is technically not a special case, but a lot of times students will get confused with this. When I go to get this x alone, we're going to subtract 6, right? But when I go to subtract 6, what happens? What happens over here?
0.
It's 0. Now this does not mean no solution. There's an answer to this. We need to do what to get x alone? By what? Divide by negative 8. Now 0 divided by anything is just 0. So like I said, this one a lot of times students will think, well, that must be no solution. 0 is a valid solution. You can score 0 points. You can get 0 points wrong on your test. So 0 is an answer. It's okay to get that. So don't think it's automatically no solution. Okay? All right, so our next one here. This one I think is set up nicely for substitution. The x is already alone. We go to set up that for the x. So this has to go in place of x. So that's going to replace our x. So careful, we're replacing a different variable. So I'm putting this in. So take a minute to make sure you're okay with that. So we replace the x with that negative 14 minus 7y. So, ready to distribute? 4 times 14, 56. Anyone? Yeah? Okay. 4 times 7, they're both negatives, can become a positive 28. Now I'm going to put those y's together. Since they're on the same side of the equal to sign, they just go together the way they are. So I have 56, and then this is going to be 28 minus 14, so 14y. I'm going to move that 56 over. So I'm going to get 14y equals a negative 28. So I'm ready to divide by 14. Some bigger numbers here, but they all work out pretty nicely. So y ends up being a negative 2. Once we have y, then we need to take that and substitute it back in to find x. And it kind of becomes one like the one we just had, where I substitute that back in, and negative 7 times a negative 2 is a positive 14. And so we end up with x being 0. So again, it might look like it's going to be a special case, but it's okay to get 0 as an answer. All right, so we're going to finish up with this last question. Big word problem. It probably looks scarier than it is. And we do have a worksheet for our homework tonight that has a word problem on it as well. It has kind of a sampling of everything we've been doing, graphing, substitution, kind of all the different types here. So it says set up a system of equations and solve the problem. So it says the senior classes at 2 high schools plan separate trips to New York City. The one high school rented and filled 1 van and 6 buses with 372 students. The other high school rented 4 vans and 12 buses with 780 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? Now, rather than just trying to guess and check, like being like, oh, van, that should be about 7, and then a bus should be more like 40. Like, we don't want to do that. We want to actually set this up. So what we're going to set up is 2 equations for the 2 situations. Now, looking at the question, how many students can a van carry? So I'm going to pick V as my unknown, as van, like the number of van kids. Now, I don't like using B for bus, but I'm going to use a capital B. A lowercase b a lot of times looks like a 6 when I write it. So I'm going to use like an uppercase, but otherwise I won't remember what anything stood for. You could just use X and Y. Now, the first high school rented and filled 1 van and 6 buses with 372 students. How do you guys think we should set that up? Yeah, what do you think, Reed?
V plus 6B with 372.
Yeah, so, and I might even write 1 van plus 6 buses equals 372 students. I don't know how many people are in each of those things, but we're going to set up an equation to help us with that. Then the other one, hopefully once you set up that one, this next one makes more sense. We have 4 vans now and 12 buses with 780 students. These are high schools slightly bigger than Random Lake High School, because that's just their senior class. All right, now we need to solve this system. Again, rather than just guessing and checking until we come up with an answer, this is a system that can be easily solved using elimination. Do you guys see what we could do to this?
Yes.
What do you want to do? What are we going to do to eliminate here? Multiply the top by 2. What kind of 2 though?
Negative.
I would say to multiply the top by a negative 2. You could also do a negative 4. I like the idea, I was thinking 4 to begin with, but negative 2 I like a little bit better. It's a little bit smaller numbers, a little bit easier math to do. So negative 2b minus 12b equals, help me out, negative 7 what?
744.
44, okay. And underneath that, now we should be able to add these together and be able to solve our van and bus dilemma here. I'm sure Rachel does this with our buses, right? Like does a system of equations. So the 12s cancel, the b's. -2 and +4 is a 2v. -444 and +780 is going to be a +36. I don't know what kind of bands these are, but there's some big bands. We're going to divide by 2. And the V is going to be 18. And 18, it's people per band. Right? Now that I know the number of people on a van, then I have to take that and figure that out for our bus. And so I'm going to put the 18 back into that top equation because the numbers are a little smaller and easier to work with. We get 354, I believe. I'm going to divide by 6. And I believe we get, so that's going to be 559.
Yeah.
So we're able to find those out. And those wouldn't be numbers I would have came up with to begin with. I wouldn't have said like, oh, that sounds about right. Again, I don't know what kind of bands these are. Those really fancy bands or something. But so I'm going to get you guys your worksheets. You guys have time to get working on that. This is due next Tuesday. You guys have a short week next week.
Next week and the week after that.
Yeah, 2 weeks in a row.